Hello, everyone, and thank you for joining us here, the NeuroTechSF Hack Night for September 30, 2021. Thanks for joining us. Okay, as always, I'm going to make sure that the YouTube stream is up and running. Although I have to admit that the Crowdcast stuff has been quite reliable and it's been going really well. So very happy with how that's working out. And the video archiving is nice. You can go back to the event and see it. Hey, look at that. We got audio and sorry about the duplication. Cool. Looking good. All right. Welcome. Tonight we have a cognitive load and VR focused hack night. I followed up on a few of the things that we talked about last week with the HP OmniStep G2 in particular, but also how they're positioning it in the market and what they're going to allow access to and what they're going to do. I think the details are really quite fascinating. So very excited to chat about that. And I put together some comparisons that we can look at from some of the pilot studies that we did. Because talking about cognitive load is nice, but without some data to look at, it can be a little hard to orient ourselves in like, what do we really mean by cognitive load? How does it show up? Where does it, what? So I've actually got some video that we can look at, and I've got some reports that we can look at, and I'll try to show you the differences in the task performance that we saw for this particular data set. So tonight, yeah, we're going to be looking at data. We're going to be talking about cognitive load. We're going to be talking about VR and skills training. I think is on the horizon. This has been something that's always been very interesting to me, which is employers have a sense of what people's skills are, and they certainly know what experience that they've done and what they're doing on a regular basis. But the process of deciding, hey, this person wants to step into a new role, we know that this new role requires these new skills, and we're going to put them in a training program. How do we know when they've learned it? I think that's the number one question that it seems like along the way, HP is trying to answer with the OmniStep G2. And the short version of it is I think cognitive load can kind of be the answer there, which is when you don't know how to do something, it's very demanding. You're going to be pretty slow at it, and your brain's going to work pretty hard. After you've done it a few times, it gets easier and easier. So it always seemed to me that cognitive load could be a proxy for how well do I know something. When I don't know something very well, for an equivalent unit of time or output, my cognitive load will be higher. And if I know very well and I'm practiced and I'm familiar, then my cognitive load should be lower. So I think that's kind of a really, really fascinating thing to consider, which is like your employer will actually be able to know for sure how skilled you are at something. And I do think that kind of opens up this interesting new ways of dealing with employees, right? Right now, what we do is very job title based. You are this type of practitioner in the company, and that's what you do. But if we took it back a level, we kind of looked at people as a collection of skills. Then that would be kind of interesting, because maybe you wouldn't have such a specific role. Maybe you have sort of a portfolio of things that you know how to do quite well, and people in the company can engage and use those skills and resources. I do think we're heading to that way. So I think that's kind of a very fascinating example. And I will bring up a tangible example of this. And I know people have very mixed opinions, but Amazon. Right now, Amazon is in the news. You know, they have all these warehouses, and the narrative that was previously attached to Walmart in terms of substandard wages, exploitative labor, et cetera, is now on Amazon. But in addition to that, Amazon has ton of people at all these locations, and they've been investing heavily in a program to train any warehouse staff that want to move into like the more IT type roles, HR, programming, anything, any of the office type tasks. They're big on board with that. Now, I get that Amazon doesn't get a lot of credit for that. fair enough. But it is a big program that they're doing. And I think that kind of really shows you that there's a big appetite on the employer side for a quantification of employee skills. And yeah, so it seems like that day has arrived by virtue of HP launching a product. But yeah, it's really cool. They've actually gone and built a portal and some other stuff. So let's start with that. Before we even get into what the cognitive load is, I just thought this was really, really cool. So this was a presentation HP did at this Augmented World Expo. Now, I have to say, I've never, there's a lot of these VR expos and so on. But the really cool thing, let's see, let's skip over to, okay, great. And I'm going to go ahead and share the screen so you can actually watch this video instead of listen to me describe it. Ah, yes. No. I just wanted to cue it up. Hey, John. Awesome. I'm going to go ahead and share screen. Sweet. There we go. Okay. And now I'm going to select the HP tab. All right. Out of curiosity, does the sound come through? If anybody can tell me one way or another, I can mute it if it's too loud or anything like that. All right. Oh, echo. Trying to check that out on the iPhone was a bad idea. Okay, so anyway, let's just skip through it. Here is the training stuff that is going along with this. This is really cool. So, if you wanted to train an employee for a hazardous situation, here's one way to do it in VR. You can make sure that it's like exact specs. Pretty cool. Now you'll note that the display actually shows the person's heart rate and some other stuff. I'll see if I can get a better image of that. But this is basically the training module, right? This is you learning how to do the repair or enact the skill on the thing. Okay, but this is where it gets really interesting. So what are we looking at? We have a rating for the skill. We have like a safety aspect of the skill. So maybe you can do it quickly but dangerously. So that's not good. Then how well have you done it? And what was the quality of your work? Now the cool part is that's going to get reconciled with, check this out, heart rate. So heart rate and heart rate variability is an excellent indicator of cognitive load and stress. When you're stressed, let's see, your heart rate gets very regular and tends to be elevated. And when things are fine, your heart rate lowers, but it also gets far more variable. So if your heart rate is very, very consistent, it's a sign of high stress. And if your heart rate has a lot of variability, it's a sign of low stress. So now you've got kind of two components, which is the heart rate tells me how difficult this was, right? In terms of, was it stressful? Was it challenging? Was it confusing? Was I bewildered? Something like that. And then the cognitive load, basically, how much of my resources was I using for this task? And I mean, these are two really, really fascinating things to consider, because if you have this information, you understand something about the learner and their journey into knowledge. Like you basically say, okay, I mean, if the first time you did it, here was the values, and the next time we see the drop and so on. Okay, cool. So they've actually set up this whole platform for this on the back end, which is actually really, really cool. And I thought that this was actually even, I mean, the in VR, whatever, but this is awesome. Okay, so check this out. Here's our human resources portal, where our humans really are resources with skills. I mean, this is pretty cool to me. Okay, so here is our person, then we have what they do, then the success rate of their training, and what training path they're on. So presumably, you sign up for programs, or you participated in trainings that are relevant to you. Then you've got your history of all the training events that you've done. So this really lets you see progress over time. It also means that if you have continuing education or certification, then you would potentially be able to track that progress and say, oh, okay, here's how they're doing. Then on top of that, second, is this still live or did it cut off? I swear it cut off. Yeah, all right. So I'm going to fix the YouTube stream later. In the meantime, you've got the score, you've got which attempt, you've got skill difficulty, and then you've got this summary of significant events within the training exercise. This is pretty slick. And then you've got the heart rate. This is your variability, right? Your mean, your minimum, max. So the mean tells you whether it was elevated or not. And your min and max gives you your variability. But here we go, cognitive load. And presumably they've got important stuff marked in red or something like that. I'm not sure how the highlights were selected here, or maybe it highlights the low point and the high point, because that could also be the case. But HP has come up with an algorithm that we'll actually dive into. They've published a lot of the information, so I'm very excited to talk about that. But yeah, they give you a percentage, 0 to 100% cognitive load, and you should be able to see this history over time. So this right here, I mean, they don't call it that, but really this is your learning level. First few times you do something, you're going to have a high cognitive load and a low score. And then over time, you cross over, and then at some point, you've got a low cognitive load and a high performance. And I hate to use some of these car analogies, but if you imagine sort of learning to drive, for anyone who's gone through that exercise, when you're first learning to drive, you first sit down, it's super overwhelming. You have to think explicitly about every single action. You have to think about where you put your arm. You have to think about looking at the mirrors. You have to think about, how you move your hands on the wheel. Like that takes people a little time to get used to. Do you cross them over? Do you shuffle steer? Stuff like that. And so all of these are going to be indicated by two things: high cognitive load, because you're consciously thinking, how do I move my hands on the wheel? How do I, where do I look? Oh, I got to check the mirror. And then the performance is really low. But as you acclimate to the task, that changes. And this is sort of like a graph that you would expect to see for any learning experience. One other thing that isn't here, but I thought I would mention is implicitly, you could also calculate a rate of learning, because you can calculate how much time they're spending being exposed to this training. You can calculate how many iterations that they've done on the training, which means not only can you calculate whether employees know something or not, you can actually figure out how quickly they learn something, like which employees need a lot of training sessions to learn a new skill and which ones don't. So yeah, I really thought I'm going to go ahead and stop the share for a moment, make sure the crowdcast is still running, and all that other stuff. Oh yes, power law practice. Yeah, I'm sorry that, excellent. Sorry that the YouTube went out. You know what, I'll just upload the recording to YouTube afterwards, so we won't mess with it. Okay, cool. Oh no, it absolutely is not based on just heart rate. So let's talk about those metrics. Any questions you have about cognitive load, employee skills tracking, or whatever, now is a great time. The major thing that is being used to calculate those is going to be pupil size. And so they have the Tobii eye tracking built in to the HP OmniStuff G2. And pupil size is actually one of the best indicators of cognitive load. And I've got some videos ready to show you examples of people doing various tasks and generating various pupillary responses. So I think that's going to be a fun thing to talk about. But yes, the probably, if I was to guess like a weighted metric, I would say 70 to 80%, they're looking at pupil size. And then, I don't know, 20%, they're looking at heart rate. And I think the heart rate would largely be supplemental, just like you could, we're also looking at other metrics like skin conductance. Now, they don't have a skin conductance sensor in there, but that would also give you stress. You can look at temperature. I think they have a temperature sensor, and some other stuff. So you can definitely have additional metrics, but I think the primary ones are going to be pupil size and heart rate. Okay. And let me just, okay, so Ryan had a lot of info about AWE. Okay. All right, heart rate. Excellent. Okay, great. Now, yes, that's another good one. A lot of these sensors give you PPG, which would give you heart rate and respiratory combined. I think that the HP Omnicep is just a heart rate sensor. However, the Emotivit, which we've talked about a few times, and the awesome project from OpenBCI, drop it in chat. The Emotivit is like a $300-400 device ish. I mean, just with all the add-ons and so on and etc. But you get GSR EDA, temperature, PPG, respiration, oxygen saturation, and they've got those three sensors. They've got the green, the red, and yellow, or blue, I'm sorry. So my understanding is that they're going to be shipping beta units in February, and that they're going to be shipping in quantity in like June, July. And so I think we could absolutely have that. We could, cognitive load. Sure, Itamar, it's a great question. Cognitive load is an attempt to measure how hard your brain is working at any given moment. And so a representation would be like 0 to 100%, where 100% is your brain is working as hard as it can. And if someone was to ask you a question, you would have difficulty responding. Another very classical measure of cognitive load is response time. So the reflex, the 200 millisecond response time thing, if you are doing a task that has you under high cognitive load, your reaction times will increase. So you can even infer cognitive load from sort of processing time, reaction time, and so on. But yeah, the most typical way cognitive scientists measure it is with an eye tracker and with yes, and that's an excellent observation, Alex. There's sort of two aspects of cognitive load, which is resource consumption, and then I guess like what you're actually processing. And so a lot of the cognitive load studies use what's called WMC, working memory capacity. And so they will give people a task like memorize these 3 objects, memorize these 7 objects, and memorize these 10 objects or whatever. They pick these numbers of things to remember that they know are either easy, medium, or hard. In those experiments, pupil size actually predicts how well people are going to do on the test. So it's actually really wild that there's this nice linear relationship between how I guess remembering things might be a very specific type of task that is hard for your brain to automate. So it ends up being a good metric. The reason I go into all this detail is when we were trying to replicate various cognitive load studies, the working memory capacity ones, we had a lot of difficulty replicating. And my suspicion is that in a strange way, working memory cognitive load is a completely different animal than task processing cognitive load. And I know that sort of muddies the water. Now we've introduced 2 concepts of cognitive load. It's like, and to begin with, it's a little dicey, to understand. But yeah, absolutely. So Okay. Any other questions on cognitive load? And yeah, great question. The way we structure this meeting is we try to like have a presentation type thing for the first little bit where we present some material, we talk about the topic, whatever, and then we have really general discussion sort of starting around 7 o'clock. Anyone wants to chime in or whatever. So I guess we try to pick a topic that we're going to dive into and kind of like discuss for a while. And then once we've got that teed up around 7 o'clock, we basically open it up, invite people, and so on. And it's just, you know, we're trying this format with the Crowdcast, and it's an excellent question. Okay. Ah, yes, excellent. So Ryan noticed some differences in his memory stuff. And yeah, absolutely. It was just really interesting to us that we're actually going to do some experiments where we try to isolate the way that the working memory capacity stuff scales with number of things that you're trying to remember. And then in addition to that, we're going to look at the way that it's task-specific scaling as well. So within games and so on. Okay, let's talk about the fun stuff of what are we really talking about with cognitive load? Because I think there's a lot of questions about it. Okay, so companies are going to be using this to evaluate us and our skills and how we're doing. Clearly, VR training and so on is going to be very exciting. Oh yeah, sorry. There was a question about EEG. Alex asked about brainwave states contributing to learning. Yes, the OpenBCI Galia, which is coming in the summer, is sort of like the next iteration of the HP Omnicept G2. So the HP does not have any EEG, but the Galia does. And that is a collaboration between Tobii, Valve, and OpenBCI. So starting, I think in about a year or less, there will be a device that allows adding the EEG component and actually has a lot more sensors as well. So that's definitely on the horizon, and that's definitely going to be there. But I think for a variety of reasons, HP did not include EEG in their Omnicept hardware. Okay, excellent. Let's take a look at the, so I've got a video queued up. Let's go ahead and share the screen. And then we're going to start taking a look at some cognitive load metrics. And then I'd like to show you what that actually looks like in data. Okay, so you should be able to see the screen. Cool. All right. And let me just make sure. See if I can get the chat without bombing out the event. Oh, I don't know why. Oh, because I've got the, gotcha. It's not muted. Okay, so yep, it's working. Great, awesome. So this was an attempt to start isolating cognitive load, and the number one thing I'll draw your attention to in the top right of the screen is the pupil size. Then below that, we're looking at the fixation length in milliseconds. That's how long that person's been looking at that particular object. Then below that, we have the frequency spectrum with an attempt to fit a line. And then on top of that, we have their brainwave specific activity. So basically, you get a little bit of EEG, you got a little bit of pupillometry, but really, we're just going to be focusing on pupil size in the top right and fixation in the bottom, or I'm sorry, middle right. So the pupil size is in millimeters. This is a raw metric. People's eyes will range from 2 millimeters to 7 millimeters, typically in pupil size. So you're going to see that they are pretty responsive. Yes, excellent question. The right eye is the white, the lighter colored line, and the left eye is the red line. And I know that's kind of like confusing, but yes, we do track the pupils separately. And this actually ended up being very useful for several experiments. But that's correct. The pupils are not identical. They have variation in terms of one is typically a little, well, sometimes they're pretty much the exact same size, but sometimes one eye will be dominant. And sometimes the dominance will cross over during a task, which is actually really interesting too. So we've discovered that by tracking the pupils separately, we get a lot more understanding into what's happening, and it doesn't cause any problems. So what you're going to be seeing is kind of two lines representing each eye. Now, when there's a blink, you're going to see a dip like this. And that's because the size of the eye is temporarily 0. And so the eye tracker does a few samples as the eyes are closing, realizes, oh, okay, the eyes are closed. The data becomes invalid. We stop rendering, and then we recover. So you're basically seeing the blink happen when you get this kind of drop. And then over here, you'll see this is sort of the linger time for each element. If someone spends 1.2 seconds looking at something, you'll see this climb up to 1200. A search type saccade, an eye movement where they're searching around, depending on the person, is going to be kind of like 200 to 300 milliseconds. Excellent question about blinks in EEG. Yes, except we are deleting them. So no. In other words, if we weren't pruning blinks from the EEG, you would see all kinds of spiking and stuff. But because it's really hard to look at EEG with huge destructive spikes, we remove the blinks as much as we can. You might see an overlap between the EEG data and the blinks, but we do try to filter them out. Okay, so let's actually look at this now that we've talked about it for a minute. Here is this training task where the person is going to be shooting a target. And there are 3 different subtasks that we've got for them here. The first one is called the MultiTarget. Go ahead and pause it. So what this task does is it presents a variety of targets for the person to engage with. The task starts out fairly easy. It's going to start out on level 1. That means that the targets take a long time to appear on the screen. It also means that the person has a decent amount of time to engage with the target before it goes away. As the task continues, it gets faster and faster and faster, so that it gets quite challenging at the end of it. So it kind of brings into effect several things. You've got strategy and you've got load. And now we're actually going to look at this and take a look at this person's performance. So the first thing is we're going to take a note of the eyes. Where we are right now, we're at 3.32. When the task started, we were about that. Let's see if we can measure. Okay, so we were about 2.8 when we were idle on this screen. So 2.8 is kind of our baseline. We're going to say that's our not very exciting level. And so we're going to say that when this person is doing a task is more cognitively loading than sitting there. And why do we say that? Well, because our pupil size has gone from 2.8 to 3.2. Now, this sounds kind of circular or whatever, but you'll see that there's a consistency there. You'll see that this pupil size really matches what's going on the screen and how intense it is. Okay, cool. So this person engaged with that target, which means that they were fixating on it for the whole time. And as soon as they shoot the target, the fixation is going to break. Why? They're acquiring the next target. So you'll see, okay, their eyes moved, right? And now we're doing this back and forth. I'll explain that in a second. But fixation ends, pupil size stays. So this is how we track cognitive load. And this is how you can assign a time component. If you really wanted to, you could say this person needed 1.4 seconds of time to engage that target, and that's when they got rid of it. Okay, so now they're handling this target as well. This one only took 800 milliseconds to engage. So pretty cool. Now, here the cognitive load is around 3.2, but already we're starting to get to the point where the person needs to start chaining these targets together. Now we're from 2.8 to 3.5. So our pupil size has increased 15, 20% already. Okay. Now, the eyes can start to show an interesting pattern here. It may or may not show up, but let's see it. But this circular thing is actually showing you, the start and stop of each event, right? You've got this pupil drop, you engage the target. You've got this rise as you pull the trigger, then it drops as you search for the next target. Sometimes if there's a continuity like this, it'll keep building. But basically, when the person is shifting gears between tasks, you'll note that because it's sort of a drop. And when it's a continuity of an existing thing, you'll typically see that because it's kind of like a building or an increase. So you can really see how responsive the pupils are. You can really see how they indicate cognitive load. You can really see how the pattern of the pupils and the fixations kind of gives you a good mapping of what's going on with the stimulus. Okay, let me check the chat real quick. See if there's any questions. Excellent. Pupil size varies with external stimuli. Yes. There are several factors that can affect pupil size. How much rest you've gotten, the lighting conditions in the room, the lighting conditions on the screen itself, and a bunch of other things. I think you can control for the lot of the ambient variations by having light control in light meters. Similarly, you can assign pixel and lumen values to monitors. So you can get pretty precise in terms of light management and light awareness and so on. And at the same time, I think you'll find that within a task and within a subject for performance, it kind of washes out. So yes, if you're looking to do long-term trend analysis over time, you'll definitely want to have some kind of light normalizing aspect. And if you're just looking for some comparisons of like, oh, what happens when people do this? For sure, if one day it's really bright, their pupils are going to be smaller. And the next day, if it's really overcast and cloudy and the sun's out, or they do it at night, their pupils are going to be a lot larger. But the ratio of what's happening within should be the same. So like, you'll get smaller responses when the light is brighter, et cetera. But the overall scale of it should be similar. So yeah, it's pretty cool that you can start to see people engaging with the targets basically through these jumps, right? Like here is this person did a target, this person did a target. So if you want to get a sense of how precise cognitive load is, it can actually see when you're actually thinking about a target versus when your brain is idling as it switches between targets. Like that's how precise the cognitive load is. And that is really, really different than some of the other sensors. Like when you're talking about skin conductance, that is definitely a long-term type of response. And on the order of several seconds. But man, this pupillometry-based cognitive load, and I think this is why cognitive scientists have had by far the best success with it, is just so great. If you're looking for the book that I found the most useful to understand this topic, Dean Kahneman's book, Thinking Fast and Slow, just really kind of will help you understand cognitive load. Now, it is a very dense book, but it's a very thorough book. So it's tread. I mean, it's good. There will just be some work involved. So the pupil, this is really, really responsive. And if we skip, all right, so now we're at 3.6, 3.7 millimeters. Let's skip to where the task gets a little harder. Let's see if we can get to level 4. All right, so interestingly enough, we really aren't seeing a big shift in pupil size. And in fact, if anything, this person might be a little overwhelmed. We had discussed this previously, like, hey, there's this traction zone last week, and if you exceed it, you overwhelm them. But yeah, we didn't really see any big shift in the first training task, this classic one. The next type of thing I'd like to show you with cognitive load is a slightly more specific one, but I'll be showing you in the data how it's different. So I also want to show you in the video how it's different. So in this one, it's testing your reflex or your reaction time. By the way, here's a series of nice blinks. So you can really see how clearly that rhythmic blink pattern shows up. Okay, So the last task was to engage as many targets as possible, as quickly as possible, and to not get overwhelmed when it starts ramping up the number of targets. This task is about reaction time. So the game will only give you 1 to 1.5 seconds to spot the target, get your cursor on the target, shoot the target. You can only pull the trigger once. So if you miss on your first attempt, that's it. The target goes away. So you get one chance, it's time pressure, and it's not enough time. That's really the thing that is salient here. Okay, so here is the target appears, person engages, and one of the things we noticed that was pretty cool is people have different strategies in terms of how they move their eyes. This person kind of glances at the target, glances back at the cursor, and guides it in. This is a fairly standard type of eye movement that we saw. And there is another type of eye movement that seems to be associated with like the more experienced players, where they can force themselves to not do that extra step where they watch the cursor and they actually just stay fixated on the target. But my suspicion is that that's a learned skill. And so by default, it seems like most people have this pattern of, I watch the cursor with my eyes, but the really advanced players seem to, my suspicion is, get to the point where that's inefficient, and they can do more by being aware of the target will give them better situational awareness and information about the scenario they're in. Okay, so person shoots the target and then recovers to the midpoint, and they're going to get a series of these where what's happening is, so we went from 3 to 3.6 on that response. So this was a fairly big onset. And what's strange is that I had sort of expected that having multiple targets on stream would generate stronger responses because your brain's working harder because you have to track multiple targets, and you have to keep them in mind, and you have to make a sort of plan of what order you're going to do them in. I certainly thought that this task was simpler in the sense of, one thing shows up on the screen, you got a fixed amount of time, hit the target, and you're done. So I really thought that this would be by far the most boring. I thought that this would be like, generate the worst data, whatever. Well, much like football, and that's why they play the games, that's why we collect the data, because that's really not what we saw. What I saw was that there are these really pronounced responses. So interestingly enough, because of the sparseness of the stimulus, because you're going from kind of this off state to this on state to this off state, it really actually brings out the differences in cognition and pupillary response. So I've got a report that's going to highlight that. But here is the surprising thing. We went from 3 to 4 millimeters on the single target task. I don't know. That surprised me, but I thought it was pretty cool. Now you can see the same type of pattern emerge that we saw in the last task, which is each time you engage a target, you get this little bump. You either bump upwards or bump downwards, depending on the overall trend. Are you finding the task more difficult or less difficult? But yeah, you can see each target engagement showing up in the cognitive load. Now, one last thing as we talk about training stuff, there you can have complete confidence whether a person saw a target or not if you have this kind of data. Why? If you don't get a pupil response, you know that they didn't parse it. So that really gives you a knowledge of the subject in a way that you wouldn't get any other way. You can ask someone, hey, did you understand what I was talking about? Yeah, sure, they'll say yes or no. But with this, you can actually look at their responses and be like, did they process this or did they not? It's pretty wild from a training perspective. Okay, so that is the second task. Now, here is the last task that we're going to look at. This is a shooting gallery. This one ended up being really awful, except it generates really, really lengthy fixations as people try to shoot the targets. So this one is not interesting. This one does not excite anyone. I'm pretty sure it's actually incredibly annoying because you're just trying, like, come on, you're struggling with it. It's not enjoyable, but it generates fantastic fixations. Like, look at this, we're in the 4-second range. So each one of these tasks really let us look at these players from a couple of different perspectives. One of the tasks helped us understand what is this person's strategy in terms of when they're overwhelmed. Okay, when they've got too much going on, and we know it's going to be too much because it always ramps to the point that it's too much. What do they do? How do they handle it? What do they drop? And what happens to their pupils? Because we can see, right, they're slowly getting overwhelmed. And sure enough, like right at the end, they're tuned out. They don't care anymore. The second task really lets you see, okay, this stimulus reaction based, what does that look like? And what kind of emissions does it generate? What kind of cognitive load does it generate? And then finally, okay, this sort of like track an annoying object type of task. What does that generate? All right, so I'm going to go ahead and stop the share for a minute, and we're going to take a look at a whole bunch of reports and data, but I just wanted to take a moment and check if anyone had any questions or wanted me to follow up on anything that we mentioned. Beautiful. Okay, let's take a look at what these reports actually look like, because now we've got 3 different stimuli. We have an understanding of what's different about them. Why don't we look, what does the report tell us? Okay, so I'm going to go ahead and share the screen here. Cool. So the first part is the combined report, and then I'll show you some of the individual details. But here is the pupil diameter for the subject over time. And you can see the first set of tasks generate one set of responses. And then you've got sort of the next tier of tasks generating another set of responses. Right here, 4, 5, and 6. And then these tasks, the last ones that are kind of dull, generate fairly low responses. So for these subjects, their pupil size ranges, I don't know, from like 2.5 to 3.75. You'll notice that for this subject, their right eye tends to be a little larger than their left eye by about 1/4 millimeter on minimum and maximum. So that's pretty cool. And you can also see the distribution of where their eye size was. And so, yeah, from 2.5 to about 4 millimeters is what you got. Okay, but here's the neat one. This is the speed at which their eyes get bigger and smaller. So this is the rate of change of cognitive load. Now, this is the first 3 tasks. This is the overwhelming task. Here is the single target reaction time drill, this whole chunk. So it's actually not a fixed speed at which your pupils constrict and expand. It's based on the stimulus. It's based on what's going on. So in this time compressed single target, you get twice the speed of expansion and constriction that you do in sort of the normal tasks. I have to say that surprised me. And over here, you go into like a tripling potentially if you're looking at it. So I just never imagined, I mean, it makes sense, right? It makes sense that the variation in your pupil size wouldn't be fixed, and that there'd be situations where it needs to change quickly, like when you turn the lights on in a dark room, and there'd be situations where it doesn't need to change very quickly. And I get all that, but it was still pretty cool to see, wow, that is a huge, huge difference in pupil diameter rate of change. Okay, and then here was the other one that I thought was really neat. Now, we can look at some of these speeds. I'll drill into this in a moment because when we're going to look at the individual reports. But once again, you can see these 3 different tasks kind of compared to each other. This is task 1, this is task 2, and this is task 3. You can see how different the fixation pattern is. So I hope that this gives you some idea of sort of, yes, this cognitive load pupillometry data is really responsive. And as you change the stimulus, as you put people in different situations, you will get very, very different data. And what that allows you to do is sort of contextualize these responses. You can say, oh, when someone is doing this kind of thing, it generates larger pupil size but shorter fixations. Oh, when they're tracking a target for a long period of time, that generates a long fixation but very little pupil size. So yeah, you come up with sort of this robust understanding of the different things. Okay, and here's the last part that I thought was really, really neat. We're going to compare the data for each of the three types. So we're going to look at, 4 through 6, and we're going to go 7 through 9 as well. Okay, 1 through 3, 4 through 6, and 7 through 9. Okay, so in this one, we've got an anomaly that's kind of dragging the chart down. But you'll notice that on this one, the pupil size is 3 to 3.5 millimeter. On this one, the pupil size ranges from 3 to 4.2 millimeters, so quite a lot more variation. And on the first task, we're really range bound from 3 to 3.6. So main stuff I wanted to show you is the size of your pupils is different in the different tasks. Here, your maximum is 3.8. Here it's 4.2. This generated a higher cognitive load. The person was more focused and spending more of their resources. This was the lowest, 3.5. This task generated the least cognitive load. Pupil diameter rate of change. Everything in the first one is typically within 0.5 millimeter per second in the positive or negative. And or not per second, that's not right, but per sample, I guess. So over here you've got 0.005, and you can see that we're reaching 0.1. So here we're not exceeding 0.005. Here we cross 0.01. That's a clear difference. And over here, I don't think we're even getting a reliable 0.5 in some of these sections. Like we're looking at 0.2, 0.3 in these sort of quiet mid portions. So really interesting. Hey, there's pupillometry and eye movements. That's the last thing I think we'll talk about. And then we will start a bunch of discussion. I'm looking forward to that as well. Okay, so eye movements aren't really fixed in speed. And I wanted to show that too. There are two types of eye movements that everybody agrees on, which are saccades and fixations. And there's a third type of eye movement most people recognize, which is called smooth pursuit. If you want a definition, I would say fixation is when you're staring at something and you're not moving your eyes at all. So like locked onto something, that's a fixation. And when your eyes are moving between 2 points, like if someone calls your name and you look over at them and you're going to make eye contact, the movement of your eyes going to them, or in the case of the video that we just watched, the movement of the eyes between targets. So you finished one target, you're now moving to the next one. That's called a saccade. So saccades don't have consistent speeds. I don't think this is new information, but we sure don't seem to talk about it much. In the first task, the mean speed of the saccades was 2,000 pixels a second. 2,000 pixels, you're like, well, that's kind of useless. One monitor per second. So if you have a screen in front of you, imagine your eyes traversing from the left end to the right eye in 1 second. Boy. Actually, I don't know if that's right. No, 30 milliseconds. 30 milliseconds. So forgive me on the imprecision on the timescales, but let's just use the pixels measure because it's portable and it's consistent. And if this person was looking at a screen, their eyes would be moving at a rate of 2,000. The smooth pursuit portion was 975 and the fixation was 531. You look at the next one, the saccades go up 2,100 and the fixations get less stable. So we're from 531 to 700. So that's a 20%, 30% speed difference. And then finally, on the really boring one, look at that. Our saccades are down to 1,700 pixels. I mean, that's quite a variation. And the fixation is back to very close to the first recording. So this is 530, this is 570. I would call that margin of error. And I'd say these two are pretty similar. But yeah, pupil characteristics change a lot. The speed that your eyes move change a lot. The amount of time that you spend looking at an element changes a lot. All of these, the size of your pupils changes a lot. So by combining these metrics, by using these measurements to create sort of an understanding of things, you can calculate a cognitive load measurement. And one of the things I'm really excited about is HP has decided to publish a data set of 100 people that they collected a bunch of data on and did cognitive load assessments. First off, this is new to me. I've never heard of this data set, and I thought this was amazing. So let me put some of these links into chat. Here we go. And here's a PDF of the abstract. Here we go. Yeah, I was so excited. They have the experiment. I can't wait to. All right, let's go. So they give you this summary. Let's just go over the summary. I'm not going to read too much, but over 1 hour, multiple tasks, different level of effort. Machine learning model, 80% accuracy, they're very happy. Multi-sensor, pupillometry, eye tracking, and PPG. Okay, so they've got their introduction, they go through all the stuff we talked about, learning capacity, variance from person, information processing ability, and so on. Indicators of cognitive load. I just thought that this would be really, really cool. They tried facial expression stuff, wasn't reliable, but right here, peripheral nervous system, tracking the behavior of the eyes, cardiovascular activity, heart rate, and variability. Keep seeing this stuff. Okay, they're gonna go over the papers. I'm gonna gloss over the papers because they don't really matter too much. Method, 738 participants recruited. They selected 100 that they published. They had 3 trials. Let's see if we can, okay, this is the file order. They have the whole thing, by the way. They have the data set. They can give you each one is in a separate file. I'm gonna be processing these, but here are the 3 experiments. Varied levels of cognitive load. They have an A, B, C, easy, medium, and hard. So, I am super excited to dig into this. Here is the data they provide, and this is really standard Toby stuff, which is cool. Here is their PPG sensor from this Vitalino PPG sensor. I've never heard of it, but there we go. And yeah, good stuff. So the data set is available for download right here. It just requires a free sign up. They want your email address. It is 1.7 gigabytes. It expands to about 10 gigs, so CSVs. And it is the, let's see, where did I put the, come on. There we go, HP. Here it is. Here is all their subjects and the license and all that. And bam. So I am super excited to dig into that. I think that's amazing that HP has published this. And I think that would be such a cool project to do an analysis. Okay, a couple of things. Anybody who would like to ask questions, talk on the stage, or anything like that, please message me or say something in chat. I'm very happy to invite you on stage and chat. I would love to hear about what you think. I think there's a lot of stuff to talk about in terms of the portal being set up, the skills tracking, the cognitive load, what they're going to market with, the license model, what data availability, and so on. I think this is amazing news. But this is really good stuff. I think this will take BCI and VR training from sort of the realm of, okay, you know, there's a few people doing it in very difficult research settings, but no one else. And now companies will have this sort of mapping between what to training skills and so on. So this is, I think, a very exciting development. I really didn't have this on my radar. I knew HP was working on the OmniSet, but I didn't understand that this was their strategy, that they were this focused on the training, the skills assessment. And I think it's so exciting. I think this really has so many potential applications for neuroscience. And really, honestly, I would say this, I think, is the killer app that takes BCIs into commercial wide distribution. Oh, yes. Okay, so check this out. They talk about the license model for this data, and I really didn't believe this when I saw the slide. I think my jaw actually dropped. Full raw data for free. And I just was like, wow. All right, hold on a second. Let's see, it's right here. It's kind of one of these slides. Yeah, here we go. They tried to flip through it real quick, but I caught it. It's like, hey, that's important info. All right, hold on. Yes, bam. Right, come on. All right, cool. So look at this core sensor data SDK for everybody. Full access to raw data, including eye tracking, PPG, pupillometry, and expression. That is amazing. That is incredible. This has never happened before. So it's really cool. Most hardware companies really lock this data down. I think this is incredible. If you are a biohacker, if you're a whatever, this is, just amazing. These devices typically cost $3,000, $4,000, $5,000, $6,000 to get the data, and this is a VR headset. It gives you all. I was so excited. Okay. Academic, so they're willing to work with universities. They clearly have a program to work with that. Developer, they want you to be able to write apps to using this. They just want a 2% piece. It's actually reasonable. I don't know, 2% isn't nothing, but it's pretty low as these things go. And the enterprise is probably where they're really looking to get their money. Just from the phrasing, it's like pay early, pay often. But fair enough. You gotta get paid somewhere, and I think corporations seems like a good start point. So, yes. Oh no, I agree. I think I would like to facilitate getting one of these for NoiseBridge, and I might even need to get another one for myself or something like that. I really have to say this completely caught me by surprise. This is never. So kudos HP. I'm blown away. And okay, so yeah, this is the summary of the stuff. But they have other demos. They've gone medical. Make sure I'm still sharing. Hold on. Probably not. Here we go. This is the license scheme. And right here, you can see that that train. Make sure it's muted. The training video kind of, even for medical settings, for doctors, nurses, pretty wild. Oh yeah, and then Ryan had mentioned this. Oh yeah, well that would be wonderful. Yeah, if we, I'd like to reach out to the HP product manager on this, because I really think that it would be worth talking to them and maybe even inviting them to the Hack Night. I just to thank him so much for doing this. Look at, we were talking about this public speaking training tool, and here is, the Vive Pro I think it's called on Ovation. Yes, there it is. The program is called Ovation. Ovation VR. Yes. So this was what they had previously, and it was kind of like a training, thing for people, and then they go in VR, and you get ratings for how you did eye contact on the crowd and all kinds of cool stuff. It's pretty wild. On the other hand, I think it's amazing that a tool like this exists to help people that have that fear overcome it. Let's see if they have any docs, but do they have any? To get started. Anyway, yeah, pretty much. I would love to see the information that Ovation. Oh, let's try to go. No, we'll do it some other time. So I really do think that's amazing. I think it's cool to see this particular implementation as well. And now you can add heart rate and variability and respiratory rate and all those other things. And I don't know, that is really, really super cool. So just stop sharing for a moment. Would you, any volunteers who would like to chat a little bit about VR, things that they would like to do, questions about cognitive science? Let's see, John. What if I was to, oh no, we lost Mr. Nolte. That's all right. Anyway, whoever would like to chime in. I do think that's really amazing. Looking at the HP data, let's take a peek. I think we can spend a little more time talking about that study and how to do the analysis. And the filtering and so on. Okay, so share the screen. Okay, so for the things that are interesting to me in this study, they've created a mapping between pupil size and cognitive load. Pupil size is really going to vary, as folks rightly pointed out, lighting conditions, subject variability, and so on. But you want to know cognitive load is probably a portion of their mental budget, their cognitive budget, and that's going to be something like 0 to 100%. So, and of course, scientists love to normalize stuff to 0 to 1, because that's just how it goes. So what I'm really interested in is how they set the bounds of the parameters for these things. And then the other thing is that they did get the validity of multimodal correlation. So multimodal correlation is actually really interesting. Obviously, when you have multiple data streams, it's nice to correlate them. But when you're first starting and you haven't really dealt with any data of that type before, it's kind of like, okay, well, where do I begin? My suggestion is start with the pupillometry TOBI data. That's sort of like, we find that to be the most reliable anchor point for all the other events, because it's so responsive, it's so stimulus driven, it's so immediate, and it's so proportional to what's happening. All the other stimuli are sort of not as context dependent, which means that they're wonderful supplemental and secondary type of measurements. But over and over, I would just say pupils, eyes are going to be your best start point. And I mean, that's the same thing I would tell anyone who was trying to do a multimodal study. So yes, you can add skin conductance, heart rate, respiratory rate, EEG, all that other stuff. But if you use your pupils as kind of like the main, and everything else as the flavor, context, and additional information, it can be a little easier to conceptualize, as opposed to, I have 12 sensors and this is how they all work at the same time. So in this case, I would say we've got 3 tasks. Let's read the description to really understand the task, because they didn't give us a video here. In the low cognitive load trial, they had to do a visual vigilance task. 5 balls. They give you 1 target. dots move in a random diverging pattern. The balls move around randomly and eventually settle in one of 5 spots, A through E. You need to say where it landed. So you need to track it through the distractions. It sounds similar to I think I looked at this before, but the Achilles stuff. There's Mr. Gaz from Gaz Lab. They also try to hit you with these visual distractions, I think. And so that seems like, oh boy, all right, attention deficit. Okay, so yeah, so we're gonna say it's gonna be something of this nature where we're trying to track a ball through 5 things, and we're gonna make a prediction. All right, so it's gonna be our low CL trial. Same thing. So medium CL is same thing, but math. Oh boy. So you've got these numbers on the screen, and you have to keep track of them, and then you need to add them up. But you can't see the numbers when it's asking you to combine them. So in this video, you would have like a 5 and an 8, and then it would say, what's the sum? But the 5 and the 8 would be gone, and you would have to say 13. Okay. And oh, sorry, there's a question. Yes, the feature extraction. And by the way, I glossed over the feature extraction because, man, anytime you're doing machine learning, like you'll spend most of your time talking about that. I definitely want to dig into what they did analysis-wise, and I definitely want to dig into what they did machine learning-wise, because it's sort of like each one is a separate thing to unpack. And I don't mean to sound like I wasn't ready for that or anything like that. Yeah, definitely, I would love to also look at how they did the machine learning, because I'd like to replicate it. We've got several sklearn classifiers ready to go, and I mean, it should be fairly straightforward to replicate their 80% success rate, given that we know the parameters, given we know how they did the features and which machine learning algorithms they use. So yeah, that would be super, super awesome to see like what we end up doing in terms of like feature selection on the ML side. Okay, so the third in the high CL trial, now they added auditory vigilance. You have to listen for a beep. You have to track these numbers. You also have to track the 5 balls with the dots, okay? Spinning wheel. The wheel changes. Holy moly, this is complicated. The audio prompts, you have to indicate which way the wheel was spinning. So they want you to track the directionality of the wheel, the numbers, and the 5 balls. Okay. So they're using more senses, and they're increasing the number of things that need to be tracked. In the low CL, it's one-ish. I mean, one set of balls. In the second one, it's the visual vigilance, where you have to keep the number in mind on top of tracking where the balls ended up on the screen. And then finally, you've got this audio vigilance task. They were shown 9 tasks in a randomized trial, so they do 3 sets of 3. Funny note, that's exactly how we did our caffeine study, 3 trials of 3. I think it just works out that way because, you know, you're like, 1 isn't enough, 2, okay, we'll do 3. Anyway, it's just funny. So here, okay, let's see if we can infer. Here's the balls moving around. Here's the numbers, and I'm guessing this is the wheel. So I'm going to zoom this in a little further. Wow, that's So, okay, so they want you to keep a running total. So like you go 5 minus 2 is 3 plus 22. So you got to be thinking 25. Nice. Follow, solve. Follow, solve, listen. Nice. Yes, absolutely. They gave a sort of quantification of 80% because I think they wanted to kind of give it some metric. But I'm really interested in what they're doing here and the specifics of it, because that's how I would definitely analyze it. Okay, so here are your 3 stimuli. Now, I think that if you're starting with your analysis, the simplest start point is look at the pupil sizes, the medians for each task. What was the median pupil size for task A? What was the median pupil size for task B? And what was the median pupil size for task C? In addition, I would say maybe there's like a scaling aspect to it, because just the median value doesn't really tell you the time series, the continuity. So if you plot the time series, you can sort of see how the values are generated. Is it a linear ramp? Is it sort of a plateau that gets reached early? Or is it a series of sort of jumps and bumps? In the case of the video that we watched earlier, it's sort of a series of spikes with each target. So if you look at it on a small scale, it's kind of jagged, but if you zoom out, you just see kind of like the overall trend line. Okay, so I would look at how the cognitive load went in, and then as soon as I had some understanding of, okay, for the low CL task, their average pupil size for, I would pick a subject. I would say for this person, it's 3.5 millimeters. For the medium task, it's 3.8. And for the high task, it's 4.2. Okay. Now, what about my heart rate variability? And that's going to be looking at, you've got that sensor as well. You've got the PVG, and you want to see what was the variability with each task and what was the heart rate with each task. And that's really what I would start with. I would say those 2 things probably would give you a lot of information. And then I would say you start with, okay, here is what the pupil size is for each of the 3. And then here is what the heart rate tells me about that pupil size. That's sort of how I would look at it. But yeah, this is really fascinating. I think it's wonderful that HP made this available. I think it's wonderful that for sort of a 2-minute sign up, you can download this data. And I think it's wonderful that it's 100 subjects. I mean, it's really difficult to get that many people in. It's really difficult to put the device on, get the calibration, whatever. This is hundreds and hundreds and hundreds of hours of work that HP has just made available. So certainly is just wonderful to see that. And maybe we can even add it to the list of awesome BCI data sets. I know NeuroTechX was sort of maintaining a list of data sets out there. They're useful. A lot of people use, there's this big emotion data set that people like and so on. But yeah, this one for VR seems like it's definitely top shelf. Okay, so now I have a question, and this is sort of like a little more of the discussion type of thing, but I'm really interested what people think. This employer skills tracking stuff is super cool. It's also, I don't know, really interesting. Do people find the idea of an employer having a really detailed understanding? When I say employer, I think it's because in this setting, corporate training is sort of a large part of this market. And I rarely get a chance to ask these questions, but do you feel like, hey, I'm a person that's really good at stuff. I'm skilled. And what this will let me do is distinguish myself from my peers, right? This is actually going to be good for me because my employer will realize how valuable I am. The other aspect is, you know, now I've got a whole other set of hoops to jump through. It doesn't matter if you're just doing your job well enough. It doesn't matter if you're, meeting the performance is set by management. You've got sort of this other component to it, that the company has insight into your abilities. And I'm really, really curious if anybody has any comments, or I would just love to hear whether it's like, yes, I'm excited about this. No, I'm, nervous about it, or I'm kind of ambivalent. It could be good, it could be bad, type of thing. But yeah, I'm super excited to hear, or super interested to hear what. Man, when I was working for the IT security thing, I'm trying to imagine how I would have felt about it. I think it would have been cool to me that instead of having like my boss wonder, like, hey, is that one of the folks that knows what they're doing? They're fully up to spec, whatever. And over time, to, of course, figure out that you know what you're doing. But it seems to me like having a way to show your boss that you're capable, or, show your company that you have the skills, is like a great thing. Another thing that this was pretty wild to me was KFC made a VR training tool, I believe, that allowed people to like practice for how it would be to work in a KFC, even though they didn't. Like they would actually teach you the procedures of their kitchen. Like, here's how to work the deep fryer. Here's how to work the, whatever. And so it really seemed to me like if you wanted to apply for a job at KFC, the way that you would qualify yourself, I mean, this isn't reality yet, but the way you would qualify yourself for the interview seems like you would go take this VR training course. You would tell them, hey, look, I'm a qualified chicken operator, and yeah, like, you should consider my application. So I wonder whether this will be like a requirement for applying. You have to go through our training because you can just do it with your own VR headset, or if it would be more like, oh, welcome to KFC University. Yes, and I think privacy, I think biometrics, I'll sort of mention this lightly in passing, but when you collect this kind of data, there's the possibility of incidental findings. Excellent. Ryan, welcome to the stage. I would love to hear your thoughts on the privacy. Anyone else? We can support up to 4 concurrently on the stage. So anyone who would like, yes, we have a question. Sorry, Inamar, I will also get to you in a second, but let's get Ryan on the stage. Hello. I don't hear you. Yes. Mm-hmm.
Yeah, so this is a very interesting topic, and I'm very happy people are bringing up privacy concerns because
Yeah.
I know whenever I've talked with companies about this stuff, I always am like, what is the privacy like when you're doing data and stuff? So it's actually funny because this was an AWE talk. That's actually where I've talked to a lot of companies about this stuff. I was a journalist at AWE in 2016 and 2017.
Oh, okay. Awesome.
And talked with a lot of companies there. It's not as fun anymore because now it's all big companies. It used to have a lot of creative companies and smaller groups, but companies like Boeing, Lockheed, like a lot of Google, there's always a lot of big companies there, and now HP and stuff, and almost all of them, like I'd say 90% of the floor space is dedicated to companies creating training simulation systems. So
Yeah, that seems to be the
I
thing.
got to try a number of them. So there's a lot of mechanic ones, there's a few engineering ones, there's a augmented reality welding system that was absolutely fantastic. And a lot of these things are AR, but for training, all of these companies were looking at trying to also do VR training because AR training often means you still need the physical item. And if you're working on dangerous equipment, you want the early stage training to not be hands on because of how dangerous it is. So, like in the HP thing, they were showing electrical stuff like switching out conductors for wire and for a power plug, it looked like. And that is something you'd want to definitely do virtual training for before you do the real thing, um, because this would increase the safety margin tremendously during the training. um, but there are very much concerns that you are going to be scored constantly about it. It's going to end up being like school again. It's going to be like, did you fail the test? And it's often a lot of these companies, the company most of these companies actually create there's companies that create the training packages that then other companies buy or
Right,
have custom tailored. And
right.
a lot of the companies who are or a number of the companies who make these programs, I can't remember any off the top of my head, they all have weird names. um but they do kind of worry about bias and these systems being used to like give people a job pretty much, and like literally you're hinging a lot more than should be on these tool sets, which a lot of the training, like developing companies don't really want. They want this to be used by everyone at the company to improve everyone's abilities and allow people to get in more training hours. In the same way that if you want to get a pilot's license, there's a reason why Microsoft Flight Sim is considered official training. If you have even a mediocre home setup, you can use that to officially train for a pilot's license.
Right.
If you have one of these headsets, you could at home theoretically train for a large number of different tests without giving any employer your data unless you want to. But if you're doing it at the company, then generally the company will be collecting the data and end up rating people. But also, a lot of the current training things, they did not have biometrics. Most of them were VR or AR.
Right.
If they were lucky, they would use the Vive Pro Eye and would use eye tracking to check certain things, but
Right.
generally they were just using VR and just head position. Are they looking at the right area?
Right.
And are their movements somewhat accurate? Um, are they doing things in the right order? Like, make sure you turn off the breaker before you unplug the high voltage item.
Yeah, yeah, but I'd much rather
Which,
practice in VR.
yeah, yeah, it's scary though how much, like, depending on some of these training things, there was for quite a while with some of these trainings, especially the human resources type of training and like the training related to um, bias training. Like there's virtual reality like bias training and stuff for companies to get, including the military. Like someone who was like trying to develop some
Mm-hmm.
um military anti like anti-racism slash bias training where they um put you in VR and you could either be the person interviewing a virtual character who was applying for a job, or you could be, and then it would, if I think that one, then it would switch you to being in the shoes of that
Right.
person. And in this demo, they specifically had um an African American person, a Asian person, and a white person for
Mm-hmm.
both the male and female options for all three, both as the one being hired and as the one um talk like being the employer. And they, even with just like 100 users trying it out, um they found that there is in like the simple study they did, they found an absurd amount of bias
Mm-hmm.
in stuff. Like they were hopeful they'd see a bit. They were not expecting to see such an absurd amount of
Mm-hmm.
very easy to identify and notice bias. And
Mm-hmm.
they weren't even using eye tracking or heart rate or any data that would increase the accuracy. And it's kind of, will this can be helpful, but also this could theoretically be used as a reason to hire or not hire people in the future.
Or
And
promotions.
yeah, or promotions, yeah. So it's going to be a double-edged sword in certain aspects.
Mm-hmm.
Like I really hope they can make some of these tools that can be especially targeted at like executives and like the people in power, so that they, if they aren't going to be like able, if you can't get rid of the biased people in a lot of these companies, is there a way to train them to be less biased?
Mm-hmm.
Or
Well,
is,
I'm
yeah,
really
it's
interested
going to
in
be
like
a
the
mess.
skills training performance stuff because like those are like like how you can quantify bias. Like totally, it's a very interesting topic. But like HP is going after the corporate training. Hey, I'm an electrician, right? Or a firefighter, or a medical doctor, nurse, and I'm curious. I think there's a really interesting conversation in chat that brings up. Okay, you're going to get these metrics on your employees over time. I think there's sort of an implicit. Maybe I'm reading too much into this, but let me just sort of take the statement and sort of um, describe how I see it, and please correct me if I've misunderstood it. But if cognitive load has a relationship with like your mental performance, which it does, um, doesn't that mean that the employer, like implicitly, you're going to get something about your employees? So you have two electricians, both of them work fine. They do the equivalent output. Prior to this, you didn't have any way of distinguishing them, but now you put them in a training tool, and they both do the task, except one person's cognitive load is always higher, always, and the other person's cognitive load is always lower, and seems to do slightly better at the task. So it's like, okay, if that's just some subject variation, fine. But if there's sort of a neurodivergent component, then you implicitly get a lot of information about your employees just from this cognitive load. I don't want to. sometimes when we talk about these metrics, it can sound kind of sinister or whatever. That's not what I'm saying. It's an incredibly powerful and informative metric that, due to a bunch of hardware reasons, wasn't really viable prior to this. You needed people to sit down in front of an eye tracker. It had to be a very specific thing, like a training task. It had to be screen based. It had to be whatever. And yes, exactly. There is sort of, you're going to get different values on different approaches for sure. And I think it's just sort of like this comparison of employees. If you have 5 people do a VR task, now you have this way of comparing their cognitive capabilities, whereas previously you didn't. And I think that's good. I think it's good to know about people and have metrics. And we wouldn't say something like it's immoral to measure your heart rate while you're doing a fitness task, right? Because it reveals your body's true fitness level. I don't think we would say that 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 there's a I don't think there's a piercing of privacy if we use your heart rate to infer your fitness or your stress. But I think I get a little bit why I think it's close to like a polygraph, right? This idea of, I use something about you to determine characteristics about you, and you don't get a chance to tell me otherwise. I guess that's probably the part that concerns people, because you create this disconnect between what the person claims, I know what I'm doing, I'm good at this task and whatever, and the metrics say, oh no, you're not. Could be interesting. Um,
I
yeah,
also think part of it is there's also a chance that they just aren't good at VR stuff.
that too.
And that would just be like, oh crap, you suck at this? You are not a good electrician? No, I just suck at VR. um, and
Yeah.
um, that, but I do know a lot of um the companies that um were making some of these trainings. They like the reason I bring up like the bias and a lot of that stuff is because a lot of these training tutorials often have people you interact with in the training, in the like virtual characters and stuff. And a lot of the time, that can actually skew some of the data
Right,
a
right,
few
exactly. So
places have
different people.
found
Hmm.
based on um like how you interact with that character, and it instantly goes from judging person for a task to judging their social skills and stuff in a way that generally should be separated or should be completely trained separately. And it's it's just very scary how some of the like most of the trainings I saw that were being developed, they were trying to make it be just a technical thing. Like you might have a voiceover and they'd use like one of the like 20 or 30 AI generated like voices that are like that everyone knows, whether it's like Siri, Alexa, all of those types of voices, which is generally fine because a lot of those voices have been specifically developed to be either androgynous or to be very normal and like calming voice and like some things that won't influence
Hmm.
the person too much. Though it's it's going to be interesting how this biodata affects um certain companies like culture
Hmm.
and stuff, and whether they're going to where they're going to put their efforts when it comes to stuff like this.
Right.
Because I know for like electricians, plumbers, and a lot of stuff,
Hmm.
they have physical training facilities. Like I've been to one of San Francisco's electrician and plumbing training centers when I was helping paint a place next door, and we that was the staging place. And a
Oh
lot
yeah.
of places have things like that, and I think places like that would get a great use out of some of these systems if they could afford it, and because a lot of times these are places where you just go to practice
Hmm.
um or
Yeah.
to
There's
get
a.
recertification, and it's not like your employer is seeing all these like details about you. They're just pretty much seeing that, oh, you passed
Right.
training
Right.
again,
Exactly.
or you
Exactly.
got recertified.